Alright, what is going on, guys? Today it is time to actually go over MongoDB aggregations. This is something I've mentioned many times and something that I use personally a lot, but I've never actually broken down what they are, how they work, and given a couple examples on how to use them. So what I've done is I went through and I built 3 different examples, one in Python, one in Go, and one in TypeScript, all in the same dataset doing different aggregations. So what I want to do is I'm going to show you all that code, how those work, break them down. Then I also just first want to actually talk about what the aggregations are. So what these aggregations are is effectively they are a way for you to take your data out of like the database or whatever and then run it through what they call a pipeline. And these pipelines are broken down into stages. You have, for example, at the start, a grouping stage. In the grouping stage, you'll be taking a bunch of documents and you'll be grouping them together based on some parameter that they all share. Say, for example, you have, I'll just use what we're about to use, the students example. Students with the same section will then be grouped together, and then you can do certain you do certain things to that group and so on and so forth. And then there are other stages you can do, like a sort stage, a limit stage, or there's a ton of different ones. I'm not going to get into every single different stage, every single different keyword, because there are literally dozens of them, and there's not enough time in the day to actually do that, but this should give you a very good idea of the basics and how they actually work. So I think the best way to do this is to just get into the example, so let's go ahead and do that. Okay, so what you're looking at right here is the Python example of an aggregation. So what we have over here is the schema. It has a name, 2 midterms, 2 finals, and the section. So this is a simulated sort of classroom sort of thing, and then what we're actually going to be doing with this data is we're going to find the top 3 students who scored the highest in each section. So I want to find 9 students total, and I want to group them by section. So the way we're actually going to accomplish this is through these 4 different stages. The first stage is going to be the project stage. So in the project stage, we pick out the fields that we want to keep from the schema. We have these 6 fields to pick from, plus an ID, but I don't really have a use for that here, so I just left it out. So what we're going to do is we're going to pick name, section, and final 2, because those are the only ones that actually matter. So once we've done that, that is going to take our data, and one of the key concepts that you need to learn is that whenever you run it through a certain stage in the pipeline, the data is mutated when it's sent to the next pipeline. So each stage is going to have access to different fields and different data than the stage before it based on what the previous stage returns. So this first stage is going to have access to all of this. It's going to have access to every field on this thing, but then after running it through, we're only going to have access to the name, the section, and final 2. So you can see I just illustrated that right here, and then now in the sort stage, we need to order this by the final. So we want to sort our documents so that they'll be loaded into this next group stage in order so that we don't have to sort them later. So we're going to sort them by the final. So then we're going to do that here and then I'll point them out. It's still going to be in the same format. It's just sorted this time. So now we get into the group stage, and the group stage is where the actual magic happens, and more often than not, the group stage is where the bulk of your aggregation is going to happen, or I guess the bulk of the useful part of your aggregation is going to happen. And what we're going to do in here is we're going to group the data by section, and then within each section, we're going to load all of the students of that section into the array. But the key here is we've already sorted them. Since we've already sorted them, when they hit this section, they're going to be pushed into this array in order. So we're actually going to get the top 3 students at the front of this array right off the bat, so we don't have to sort it again later. So then we'll load those in, and then they'll just keep getting added, and then afterwards we're going to be left with this. So we're going to have an ID, which every group stage needs to have an underscore ID, and that's going to be what you're grouping on. So say, for example, instead I wanted to group on their final score, I would group them by the final, and then their ID would be the number final score that they all share. So it's the thing that every single document in this group shares in common that you're grouping them by. Then for the students array, this is going to be an array of the students that we took from over here, but we only need to pass in the name and final since we have the section based on this ID up here. And then once we've done it in here, we just need to do another projection, which will just limit the number of students in the students array to just 3, because we don't want to send back tens of thousands of documents. We just want to send back the top 3. So we're just going to limit those, and it'll output this right here, which is just an array of objects where the ID is the section, and then a subarray, which is an array of objects, which is the students, with the top 3 students in order. So let's take a look at how this code is actually implemented. All right, so I built out this very basic Python project. All of this is up and hosted on GitHub. Everything's down below if you want to look at it, and this The way this actually works is the first thing we have to do is connect to MongoDB. So this is very simple. I'm connecting to a localhost instance because I'm running this just on my computer. If you needed to connect to a production instance, that wouldn't be hard to do. You would just switch this out for your normal URI, but this isn't a basic MongoDB tutorial. This is more about the aggregations. So we connect, we get our collection, and then once we go in here, we need to set up our pipeline. So as I illustrated up here, the pipeline is divided into stages. So we have the first projection, the sort, the group, and then the final projection. And that's going to be reflected in the code. So this first projection right here is going to be picking out the name, section, and final two fields. So we're going to grab those fields we want and then pass the output of this stage into our sort stage. Then once we get into our sort stage, now we're going to want to order them by sections. This will group them by section effectively before we even have to group them. And then it'll order them by their final two grades. So put them in, this is the important part, is putting their final two grade in descending order so that we can then use that later. Now we want to group them by their section. So as I said, the underscore ID is the thing that they all share in common. So if you remember, after this, we had the name, section, and final. Those are the three things we have access to on each document in this stage. So I'm going to be grabbing the dollar section. Anytime you want to grab a field from the input, you have to use the dollar here. You have to use the dollar on it. So you do dollar section for the ID. So that means that all the sections are going to get put together. And then the students, we're going to be using a dollar push. So you're going to see a lot that I use a couple of these different like special functions that MongoDB gives you. There are dozens of them, so I can't get to all of them at once. What the push keyword will do is it will create a subarray within the section document. So it'll create one document for each section, and then for that document, it will push onto a subarray every time we have another student who matches that criteria and gets added to that section. It's going to push them into this array, so it'll add their name, it'll add their final two score. If you remember, we sorted them by descending before. So they're all going to hit this stage in order, so we don't have to sort it again. So they're just going to hit it in order, and then they'll all be loaded in as follows. Then finally, we get down to the final projection, which is just limiting the length of the students, or limiting the length of the subarray of students. And normally there is actually a dedicated limit stage that you could use, but here I have to use a projection because we have to limit a subarray. So if you were just limiting like the total amount, which we're going to do in the other examples, then you just do a limit stage. But here we have to limit a subarray, so we're going to do that using a slice and a projection. Finally, we just need to actually call it, and it's as simple as just myCollection.aggregate, call the pipeline, print out aggregations complete, and then print the results. Okay, so it'll connect and it will run this aggregation, print out the results. So grouping by each section, online, morning, and evening, and then the top three students. So 370, 2100, and 2200. These were the top three in morning, so on and so forth. I didn't format the data nicely, but you get the picture. So the next example we're going to talk about is Go. This one is slightly less complicated than the other one. So all we're going to have to do is find the top three students across all sections. So we don't always have to have a grouping stage. Here we won't. And this one is actually pretty basic. All we need to do is grab the fields we want, so we just care about the name and the average. And the way we calculate this average is kind of fancy, I'll show you that in a moment, but effectively we're going to use one of the special keywords that MongoDB gives us to average out these four values, the midterm 1, midterm 2, etc. Take the average of those four values and load it into this average variable, and it'll do that automatically for us. I'll show you that in a moment. Then we have the sort stage, and what the sort is going to be doing is just ordering us by the average that we get calculated here. So if you remember, this stage is going to be taking this in as an input. So this stage will be ordering by 80. This stage will be ordering by the average. Then finally, we're going to limit to 3. Again, this isn't going to change how our data looks after this point, but we could if we wanted to, but here we don't need to. So we're just going to limit it to 3 and then output an array which looks like this. So getting into the actual code of this, it looks a little different than Python. Go uses something called BSON, which is the internal sort of query language and data language that MongoDB likes to use. And it's one of the reasons why I think that Go and MongoDB play so well together is because the BSON allows adding types to MongoDB really easy, and it also makes these developing these aggregations very easy, and it gives it, I think, in my opinion, a stronger syntax than some of the other languages have. So I had this getDB collection function. That's just a basic connecting to it. There's a lot more boilerplate in Go than there is in Python, but that's more just down to the language. And so then once we've got the database connection, what we need to do is actually run the 3 stages that I showed you up there. So we start with the projection stage, which, as we saw before, if we want to just get a field, we just say name and then value equals 1, which means that we are going to include it. If we for some reason wanted to specify that we don't include it, we would just pass in value equals 0. But granted, if we don't pass in anything to the projection stage about a certain field, it just won't include it. So then we have the average, and this is sort of the fancy part of this one. And what this is going to do is it's going to calculate this average field to be the average of midterm 1, midterm 2, final 1, and final 2. So it will automatically calculate that for us because it's smart enough to say, okay, if I'm saying dollar something, dollar this, it'll know that those are fields on the specific document we're looking at. It'll take the average of all of those and then load that into the average variable. Then now that we have that average loaded into our average variable, we can then just sort by the average, limit, and then go ahead and execute it right here, and then print them out. So we do go run main.go. And just like that, we have average and name, average name. So it seems like student 615 has the highest average of all the students. Okay, so what you're looking at right here is the TypeScript example. This one is also not too terribly difficult. And basically all we're going to be doing is calculating the average midterm score for each section. So the first thing we need to do is get the projection, as basically every aggregation is going to open with a projection 90% of the time, either that or a match. And in this case, we want to project to grab the section, midterm 1, and midterm 2. Now, I deliberately didn't average midterm 1 and midterm 2 here so that I can show you how you can nest these later. If you wanted to, you could do it like the previous example, and you could make another variable called average, and then make that the average of midterm 1 and 2, pass that into group, and then use it during group. But for this example, I didn't do that. So then now when we get into group, we're going to take this as input, and then we are going to calculate the average midterm score for that section. So we add these two inputs, and we can run a calculation to print out this average. Then finally, we just sort by the average, and then output the 3 sections and show their averages. Okay, so looking at the code for this is pretty simple. All we really have here is we just connect to MongoDB up here. So we create our client, and then we connect to it. This is not a well-made TypeScript project or well-formulated, but it's meant to show you the concept. This isn't about TypeScript. And then we set up our pipeline. The pipeline is going to have at first the projection stage, so very simple this time, just including the section field, then midterm 1 and midterm 2. Then next we need to group these, and this is where it's kind of interesting, is you can nest these operators. So you can nest average and average within each other. So we're actually taking an average of averages here. So we're averaging midterm 1 and midterm 2, and then taking the average of that average across all of the different documents. So this is the average on one document, and this is the average across all documents. And then that's saved to the section, it's grouped by section, and then this is saved to average. Finally, we're sorting by average. We get the result printed out, and if we do npm run start, it takes a moment, and it will print this out. So we have the average 50, 49, and 49. And considering I built this data using a random number generator, that seems about right.